So now we have a cut, right? Now we have a cut and we have a possible definition of a negative of a cut. So let us define that set and let us check whether that definition holds good for a negative of a cut. So we start from here. Let alpha be a fixed real number. For this alpha, we define beta as the set of all rational numbers such that negative of the rational number minus some positive real number for some positive rational number for some r. Okay, this is belongs to greater than 0. You can see where these two are attaching. This is alpha and beta. This depends on alpha. This beta set depends on what is the alpha. So the first question is. Is it beta a real number or not? So how to check? We should check whether this is a cut or not. So the first property we should check, and then second property, and then third property. What is the first property? The first property we should check that this set is not a null set, as well as this is not a completely not a rational set, but this is a proper subset of the rational number set, right? So how to check a number like this? For this, we take the count that alpha is a cut, right? We know that alpha is a cut, but we want to check beta is a cut, right? Alpha is a cut, so alpha is not a complete rational number set. So this is a proper subset of it. That means there should be a rational number which is not belongs to alpha. Okay. Also, put p is a rational number, so that minus p minus 1. Then we will get that s is equals to minus p minus 1. What is this? Yes, this is a rational number which does not belong to alpha. So, and this is a rational number, right? This is one of the rational numbers. So now we are in a situation like you give us anything, we can construct such kind of, we give as any alpha, we can construct such kind of numbers such that your p is a rational number. Somehow it is managed to find out its like r which is equals to 1, which is greater than 0, such that minus p minus r does not belongs to alpha. So what is that? Your p belongs to beta, which is responsible for the cut. So now from now let us just call beta. Okay, the beta of an alpha is okay, but since we are dealing with only alpha and beta now, so let us call it as beta only. Okay, so our p belongs to beta. So what it says, this clearly an indication of the thing that beta is, you give any alpha, then we can find the beta set which is not a null set. At least we can find minus 1 for this kind of construction, so that we can find numbers like p which are not belongs to the belongs to the beta, right? So this is how to check whether this is whether beta is a null set or not. Okay. So now the next thing is that is our beta is equals to set of all rational numbers. That is not possible directly we can say, but just to look logically, say let p belongs to alpha. Let p be the number in the alpha. Then you check whether minus p belongs to beta or minus p does not belongs to beta. I will confirm this. This is your answer. This should be your answer. But how to check this? See, what is the minus of version of the minus p? That is plus p, right? So now you have plus p, that is minus version of the rational number which belongs to the p. So let us suppose minus p belongs to beta, even though p belongs to beta, right? Even though p belongs to beta, minus p also belongs to beta. So this is our assumption. If this is our assumption, then what is p minus any rational number? Those are, if it is your p, this is your p minus r, right? Then this is our alpha. If q is a rational number less than p and p belongs to alpha, then q also belongs to alpha. This says that minus of minus p minus r belongs to alpha. Despite this is belongs to this minus p belongs to beta. This is the violation of the definition of the beta itself, because the minus of an element in, let's say, q is equals to minus p. Okay, so then minus of q minus r should not belongs to alpha, at least for some r greater than 0. But this is going in a reverse way, that is minus of q minus r belongs to alpha for all r by the second property of the cut, which is applied to the alpha. So this says that if p belongs to alpha, then minus p does not belongs to beta. So we found a rational number which is not in the beta. That means beta is just a subset of it, not a rational number set itself. So our answer is beta should be proper subset of the rational number set. So the first property is done. We are done with the first property. So the second property is left and third property is left out, right? So what is the second property? If you take a number less than this number, that is, what is the second property? If we already discussed, right, in this video only, if q is less than p and p belongs to a cut, then q also belongs to the same cut, right? So this is how we have to show. So let p belongs to beta, then pick r greater than 0 such that this is possible, right? To pick an r greater than 0 such that minus p minus r does not belongs to alpha, right? If q is less than p, then what happens? Minus p is less than minus q. Then minus p minus r less than minus q minus r. We know that this is already not belongs to alpha. So this here is our alpha, here is our minus p minus r, and here we are getting this is q. This q minus r is coming greater than the p minus r. So this is, here we have minus q minus r. So definitely minus q minus r does not belong to the alpha for the same r. Then what happens? Minus, somehow we managed to find such an r, right? So so then our q does not belong to beta. Then our q belongs to beta. So then what happens? The second property says, so we took a rational number less than p, see here, okay, and p belongs to the cut, see here, p belongs to beta, and then we managed to show p belongs to the same cut. So then we managed to show q belongs to the beta. So second property is also satisfied. So coming to the third property, which is also a very easy one, you can put t is equals to p plus r by 2. Then definitely t is a greater number, greater than p. That means we should show that you give us any number, it is possible for us to find one more number greater than that. That is our third property, right? So how to show that? We are just picking a number greater than the p. Okay. Now if we show that, because if you take p, it is possible that there is an r. Then you just you just add p plus r by 2. Then you will get t. So construction of t's are very easy. It is also trivial. Like you give us p, we can keep on constructing t's. Then t. So we have this statement that t is greater than p. Well, if we show that t does not belong to the cut, then we are done. So take minus t. Okay. Then minus t. Minus r by 2, which is equals to minus p minus r by 2, and then we are adding minus r by 2, right? So we are also adding minus r by 2 here. So minus p minus r. This is the r which is, I didn't mention that, such that minus p minus r does not belong to alpha. Okay, so this is our one of the hypothesis for this statement also. So that minus p minus r does not. Now we managed to show that minus t minus r by 2 does not, because this is does not belong to alpha, this is also not belong to alpha. Therefore, t belongs to beta. So each time we can construct a greater number than the p. Now since t is given right now, since t is given, now since t is now that it belongs to beta, then let us say t dash. Okay, t dash t plus r by 2, that is which is responsible for it. So r by 2 by 2, that is r by 4. So t dash is equals to t plus r by 4. This is also this is also belongs to beta. So we can, but p is less than t, t is less than t dash. So again we can construct t double dash, that is the t dash plus r by 4 by 2. Like you keep on doing this and you will keep on getting the bigger number which are still inside the our beta. So this clearly says that we have the third property satisfied. So third property is also satisfied. Now we can clearly say that beta is a cut. Now we can clearly say that beta is a cut. You give us a cut alpha, then we can find beta, which is a cut. But is such a beta is the additive inverse? This is our question. So for this we will prove alpha plus beta is the subset of the 0 star, and then 0 star is a subset of alpha plus beta. Okay, so you give us any number in the alpha plus beta, then we will show this number is less than 0. Then we will done with this statement. Now we have to show that alpha plus beta is the proper, not proper, subset of the 0 star. We have the clear information that if if p belongs to alpha, then minus p does not belong to beta, right? So that which also says that if q belongs to beta, then minus q does not belong to alpha, right? So let p be a number belongs to alpha and Q be a number belongs to beta. Okay. Now then P plus Q is a number which belongs to alpha plus beta by our definition of the alpha plus beta. Since P belongs to Q and Q does not Q belongs to beta, then minus Q does not belong to alpha. Therefore, see here we have our cut. Whatever number belongs to here comes on the left side, which is the lesser side, and whatever number which not belongs to alpha comes on the right side. Therefore, Q is less than minus Q. So which is says that P plus Q is less than 0 star. Sorry, not 0 star, 0. So which implies P plus Q belongs to 0 star. Because what is 0 star? 0 star is a set of all rational numbers less than 0. So we got alpha and we got beta, and then alpha plus beta is a subset of the 0 star. So this is how we showed. We just took the help of their own definition of our definitions of the alpha and beta, and then we managed to prove it, right? So the next part is a little bit interesting part. You just pick say V belongs to 0 star, then show V belongs to alpha plus beta. For the same alpha plus beta, you just take any negative rational number, and then show that it is also belongs to some alpha plus beta, not some alpha plus beta. For now, just alpha plus beta. Our concerned cuts. How to show this? Okay, let just pick the number. Okay, this is need to be shown. Okay, just pick a number. Now put W is equals to minus V by 2. Since V is a negative number, minus V by 2 is a positive number, right? So this is a positive rational number. And in the last video, I told you that we are going to use the Archimedean property. So we have a number greater than 0. Let Q, which is not belongs to alpha. Okay, let Q, which is not belongs to alpha. Then what happens? There exists a number n which such that n into W is greater than Q. N into W is greater than Q. Let A be the what it means n into W greater than Q. Q is not belongs to alpha. Then NW does not belongs to alpha. So let take the set A, NW does not belongs to alpha. And then with this set, we can easily show by taking 3 to 4 types of cases, like what if alpha here and alpha is a positive number, then what if W is here, what if W is here. Since W is a positive number, it should be greater than 0. But what if alpha is a negative number, then so we have W. But what if V is here, or what if V is here? So in all these cases, it is easy to show that there exists an integer such that NW belongs to alpha, but the next n plus 1 into W does not belongs to alpha. So it is easy to show such kind of numbers. This is directly depends on the Archimedean property. Now put P is equals to minus of n plus 2 into W. Now minus p is equals to n plus n minus p is equals to n plus 2 into w. Then minus p is equals to n plus 1 into w plus nw. Just w. So now we left with minus p minus w is equals to n plus 1 into w. N plus 1 into w. We already shown that for our present situation, n plus 1 into w does not belong to the alpha. So what it says here, we have minus p minus w, which is not belongs to alpha. This is not belongs to alpha, and w is a positive number, which says that p belongs to beta. We have v is equals to minus 2w. Why? W is equals to minus v by 2. This is how we put the w, right? So now also observe that this p is equals to minus of n plus 2 into w, which will gives you p is equals to minus of nw minus of 2w. What is minus of 2w? Minus of 2w is v here. So this implies p is equals to minus of nw plus v, which implies v is equals to p plus nw or nw plus p. Why? These are rational numbers, we can do it. Now you see this n plus w. N plus w is a number which belongs to the alpha, right? So we have a number which belongs to alpha, and p is a number which belongs to beta. So here we show that p belongs to beta. So we have p belongs to beta, alpha and beta. So v is a number belongs to alpha plus beta. But observe here, v is a number which is taken in the v is a number in the 0 star. Now we have managed to show that for given alpha and beta, you take any number in the 0, and we can show that that number belongs to the 0 star, belongs to the alpha plus beta also. This says that 0 star is a subset of the alpha plus beta, which is alpha plus beta is equals to 0 star. So this shows that our beta, depending on the alpha, say beta alpha, which is a set of all rational numbers, such that minus p minus r does not belongs to alpha. This alpha for some positive number, r. This is the additive inverse of the alpha. You just try these. Write this definition with all pairs of like a pi and minus pi, then minus e and e, even rational numbers also 2 by pi and minus 2 by pi. You just try those, try to construct beta of every number, and you will find an same kind of definition. So it is easy to see now that we can say that the addition we defined on the real numbers is with the real numbers, it makes an abelian group, because from the beginning we saw that this is closed. That means you add two cuts and you will get cuts again, and in the intermediate step of the 0, we understood that alpha plus beta is equals to beta plus alpha, and also associative property holds good. There is no problem in that. And then now we are showing that for every alpha there is an beta. I mean, you can construct, right? So the definition itself is helpful to construct. So now it is easy and clear that it is an abelian group. Now what about the multiplication? Multiplication is bit difficult, but it is an easy to understand the concept of the multiplication. We will develop that definition of the multiplication in the next video.